students. Doesn't look like anybody has shown up for this one, so I guess I'll just be talking to myself for the next half hour or so. But today we're going to be taking a look at this Introduction to Circuits remote lab. I'm going to be kind of showing you around the simulation a little bit, how it works, how some of the tools inside there work. I'm going to be seeing if we can figure out how to edit the document, because I'm not going to lie to you, one of the big reasons why I picked this particular assignment was because the one I found was already in a Google Doc, which meant A, you could submit it right back to me, and B, I wouldn't have to do a lot of tweaking to the formatting to make it work. So we're going to try it out, and if we can't figure out how to make it work with Google Doc, then I'll be doing quite a bit of it on paper. So make sure you have a calculator and some way to access both this handout right here and this simulation right here, and we'll jump on in and we'll take a look and see how it works. Okay, so before you start this thing off, there are a few prediction questions that you need to just kind of take a look at and take your best guess. They've got 7 light bulbs here. They want you to pick out which ones you think are going to be the brightest and why. Now, this is just a prediction. You don't have to be right on this, but I would like you to be sure and do this. So, in the spirit of that, I'm going to go ahead and do this myself. Let me pick out a nice text color so I know it's me. Let's go magenta, because why the heck not? I'm going to say, I think that bulb number 7 will be the brightest, brightest, because it doesn't have to share with any other bulbs. Sure, why not? Current's the flow of charge. Describe how you think current will flow in the different types of circuits above. Okay, I can probably do that too. How do I think current will flow? I think current will flow from the negative end of the battery through the wires and bulbs and back to the positive end. And I might be wrong on that, I might be right. Again, it doesn't really matter. So now it wants us to get into the intro screen. We need to build a circuit that shows how to make a light bulb light up, figure out how to measure current and voltage, and then we're going to put an image of our circuit with current and voltage measured. So let's come in here, intro screen. This is a really fun simulation, you guys, because you get to play with all kinds of fun stuff on here. There's, on the left-hand side, there's a whole bunch of different circuit elements you can put in. And you can either have it look realistic, or you can click this button here to make it all schematic diagrams. And so you can represent resistors as wavy lines and batteries as that thing. I'm going to leave it as realistic just for right now. And let's see, to make a circuit, I know I'm going to need a battery. I'm just going to drag one out there. I'm going to get a light bulb. And now I'm going to take some wires. I'm going to attach one wire to my battery at the negative end right here. Take another wire. And if you make a mistake and need to change something, you can click on it and then click the scissors to open it back up. That's how you take things back apart. And I'm going to go ahead and hook this up. And oh, look at that. I've got electricity flowing through my circuit here. Now you can also hit the minus button to zoom out, the plus button to zoom in. You can grab pieces once you have them together and move them however you'd like to move them. And if I was to take this and look at the schematic version, there's my battery, there's my lamp, and it looks like electrons are flowing through my circuit, and it's making my bulb light up. To take a partial screenshot of this. I'm working on a Windows machine, so I'm going to use this cool little app that comes with Windows. I forget what it's called. It's called Snip and Sketch. But if you're working with Chromebook, then you can work with something similar to that. And I'm just going to click New. Oh wait, I don't want to do that yet. So I'm going to hit Cancel. I need to figure out how to measure voltage and current. So it looks like I've got an ammeter here. Now this ammeter is cool because it's a non-contact ammeter. What I can do is I can probe to any portion of my circuit, and it tells me that I'm looking at 0.90 amps. And that's true, looks like, for all portions of this circuit, which makes sense because this is a very simple, and remember, in series, current stays constant all the way throughout it. So there's my current. I'm going to take my voltmeter, and I want to measure the voltage across a certain portion of my circuit. So let's see. The voltage right here is 0 volts, but from here to here. Now see, that's showing 9 volts as it moves through that light bulb right there. So it's only showing 0 volts because I've got them on the same side of the circuit, but if I get on the other side of an element, it tells me my voltage is 9. So that looks like something bringing shot like new. Okay. What I want to switch. I'm going to make my computer freeze because I've got so many things running on this right now. It's not even really. So from here I could either save it as a file, or I can just click this copy button. I'm going to come over here and I'm going to paste. So I'm going to hit Control V. That's freaking huge. So let's shrink that down a little bit. Still awfully big. I think I'll shrink it down some more. Maybe. Gosh, how small do you guys want me to get it here? Okay. Maybe it'll let me move it up here. Let me move it up here. Ah, that's something you can mess around with. That's not a big deal. So I'll just leave it right there. It's fairly decently legible. Oh, until I stretch it out, that's all kinds of ugly. Ugh. Okay. So, cool beans. There's got to be an easier way to make this work. Okay, let's come up here. I'm going to put it right here, then let's go Control V right there at the end of that. Aha! That's better. Still ugly, but at least it's ugly in the right place. I know you're really excited watching me play around with this. I would be too. Okay, that'll work for me. So now let's, oh, where'd my lab go? There it is. Okay, imagine you're an engineer making a string of battery-powered holiday lights. Did I skip something? No, I didn't. If a bulb burns out, current cannot flow through that bulb any longer, like if the wire at the bulb has been cut. Figure out how to hook up 2 light bulbs in a battery so that when one bulb burns out or is disconnected, the other stays lit. I think, if you've been paying attention at all, that what we're probably looking at needing right here is going to be a parallel circuit. So let's get back into our circuit construction kit, and I'm going to reset everything. I'm going to pull out some stuff in the parallel circuit. So now let's get fancy. I'm going to bring out a switch this time. So I can switch, so I can turn my circuit on and off. Let's get a couple different light bulbs. And let's run a wire from here to this bulb. Then let's run another wire from here this bulb. We'll take a wire from here to here. We'll put another couple of wires right here and right here. Now let me close my switch. Oh, you just have to click on it. Now look at that. I have got light flowing through both. Now let me try and break one of these. Okay. Looks like one bulb has burned out, but the other bulb continues burning. So that's a success. I'll go ahead. Since it wanted me to prove that that was a thing, I'll get into my little snip and sketch here, or screenshot or whatever, and take another screenshot. There it is. Nope. Here it comes. There it is. I'll copy it, and I will, right at the end of this thing, I'll click paste, Control V. Way too big, so let's shrink it down some. Shrink it down a lot. Okay. And explain why I think it works. Oh, it looks to me like magenta. Each light bulb has its own circuit. I think I spelled that right. So even if one goes out, the other one stays put. Okay. All right. Cool. Imagine you want to make sure the battery for your string of lights will last as long as possible. A battery will last longer if it powers a circuit with low current. How could you cook a battery and two light bulbs so the least amount of current flows through the battery? Okay. So the cool thing about that is that, especially if you zoom this out, you can build several circuits side by side, and you can actually test them side by side to see which one does exactly what it is that they are asking you to do right there. So I'm going to skip that. I'll let you explore that one on your own. I think maybe there's some page breaks in there, and that's why pages keep disappearing. It's not really that important. Okay, your goal in this part, in part 2, is to write rules to describe how patterns of current and voltage in the circuit relate to the structure of the circuit. You'll need to measure current and voltage in multiple places on several different circuits. Okay, so they've given us some examples here, and that's fantastic. Telling us both what current is and what voltage is. So use the table below to record your measurements and patterns you notice. You decide where will be the most useful places to take measurements and how many to take. So in this case, label the places where you decide to measure current and voltage. Try several places. Okay, so I believe since this is an existing picture, you should be able to double click on it. Nope, that didn't work. Now this is going to be tricky, trying to figure out how we can add annotations or how we can... Is there a way to edit the image? Replace image? No. That's one thing that I really wish they would do a little better job of putting into Google Docs. Okay, this changes border color, and that's not what I want. I would really like to be able to add an annotation. So can I insert a drawing? What if I click new? Nope, it's just going to open up a whole new drawing canvas, and that's really not what I want. So I'm going to save and close that. So in this case, it might actually be easier. You can do one of two things. You can either, and I think this would be a real pain, you can open up this image and you can edit it, like by drawing some circles, or it might honestly just be easier to print this out on paper and do it on paper and scan it and turn it back in. So I think probably your best bet on several of these is going to be building these, just like they're shown in your circuit construction kit. So let me make this a separate window and shrink it a little bit. And where'd you go? And let's reset this. I'm going to build exactly what they've got built there. So I'll bring in the battery, point it the way they've got it pointed. Wire, another wire, yet another wire, which I will hook up to a light bulb. Sideways, and another wire. A little bit crazy in the here. And one more across the bottom. Okay, so I've got my circuit doing what their circuit's doing. There is label the places where you decide to measure current and voltage, and then try several places. And I think I froze my Google Docs. There we go. So since this is a series circuit, I don't think it's going to matter to take my current measurement, but let's just pull that up to make sure. So I'll take my ammeter, which measures current. Right there it's measuring 0.9 amps, 0.9 amps, 0.9 amps. In fact, no matter where I drag this, it's measuring 0.9 amps. So I have here, in this blank, magenta. I'm going to put in 0.9, maybe. There we go. Maybe trim up some of these blanks a little bit so that it doesn't mess up my formatting too bad. Now let's click and drag over all this in my lovely magenta ink. And I'm going to say the ammeter gave a reading of 0.9 amps no matter where I took it. I might just put SE to remind myself in series current is constant. I just typed all that. I'm going to see if it decides to catch up and actually type it for me. Probably not. Whoa, check it out, it worked. Except I spelled matter wrong. There we go. In voltage measurements, in a similar way, what I would do is I would measure the voltage. Now it wants me to note patterns. Where is current the same? Where does the voltage change? Where doesn't it change? And how do the different circuits compare? Now that one I'm not going to be able to answer until I make all of the circuits that are in this list here. The simple circuit, the series circuit, the parallel circuit, and then the complex circuit. Now it's going to get more interesting once you get into this point in here. Then we get into the last couple of pages here, summarize your understanding. Write rules about voltage and current for each type of circuit. It is fine with me if you want to cheat a little bit and some of the stuff that we talked about in the notes, because if you read through the notes and if you watch those videos, then you should already have a little bit of a leg up on what some of those rules and guidelines are going to be. On the very last page, it'll let me scroll down some more. We come back to that very first question. So predicting from our rules above the order of the light bulbs from brightest to dimmest. And then build the circuits, or you might actually want to fudge this a little bit. And while you have those circuits built and take screenshots, look at several screenshots of each one and see which ones are giving you the brightest bulbs. And see how well that lines up with your prediction and with how you did it down here. And then there's number 8. is asking you one more practical application. If you want to make a flashlight and have 2 batteries and a light bulb, be sure and answer A and B. A is your prediction, and then B, you're going to build things and then put in a screenshot to support your answer. So there's a lot to chew on here, but none of it is too super difficult. And I will tell you that if you get bored in the middle of this and you want to go play around with this thing, you can make circuits and you can incorporate things in there like dollar bills, paper clips, a human hand, a dog. There are ways that you can break this simulation and you can start things on fire, so feel free to play around with those and see if you can find the coolest possible way to break stuff. And I think I'm going to sign off and wish you the best of luck on this. Let me see. I don't have any other regularly scheduled live learning events for this week, so tomorrow morning from 10 to 11 is just Open Physics Help Desk, as well as all my other normal times. And I will have assignments coming up for you for the next couple of weeks pretty soon. If you haven't already read it, we've only got, less than 3 weeks to go now, because we get out of school on the 15th. So y'all hang in there till then. Do good. Catch you later.